Hello, we are going to do topic 1, section 2, arithmetic sequences and series. Okay, so patterns are everywhere in the world around you, and the distribution of petals on a flower, the position of cracks in dried mud, or the wind-shaped crusts of sands on the beach. Patterns are powerful because they allow for prediction and are visually beautiful. Okay? A sequence is a list of numbers that follows a pattern. It may be as simple as a list of positive integers, 1, 2, 3, 4, 5, or more complex, such as 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. All right? The second sequence is a well-known sequence called the Fibonacci Sequence, which is related to the golden ratio and models the patterns of the spirals in the nautilus shells. That's a mouthful, all right? I love the Fibonacci sequence because it does just that. It does a spiral. And actually, I would like to show you how you can draw it. You can start by doing a square, and then starting one way around, we're going to do, the top edge, the right edge, the bottom, and then the left. Okay, so let's start with the top. Okay, the top edge, I'm going to draw another square with this as one of the sides. So now we have another square. Then I take the right side. I'm going to make a square with that side. Then now I do the bottom side. I take a square, and notice my squares are getting larger and larger. Okay. All right, so that is, now if we do the diagonals, so we started with the first one, and that second square, our third square, our fourth, our fifth, and our sixth. And hopefully now you can actually see that spiral emerge. Okay, so people like to doodle all the time. I like to play with, spirals in the Fibonacci sequence. It's just something fun. Okay, so let's get down to it. First, we need to be able to identify sequence. So consider this example of a sequence: 2, 4, 6, 8. Can you predict the next number? All right, yes. A sequence is a list of terms. Okay, I thought I had my pen. List of terms. All right, a term is a single entry, often a number that is separated by a comma. Okay, they're usually connected by some kind of pattern. This one was with addition, and this one down here, you can see it's through multiplication. Okay, we want to be able to predict terms in a sequence because then we can start thinking like on a much greater scale, right? That's the whole point of this. Okay, so first we need to just be able to recognize patterns. Okay, so at any time, make sure you can, again, pause this video, do the problems on your own, and then unpause, see if you got the same thing I did. Okay, so A, let's see, it looks like -5. Well, I try to do addition and subtraction first because that's the easiest. And it looks like everything keeps increasing by 3. So since we're going to add 3, the next term in each of that sequence is going to be 7. All right, part B, it looks like the bottom one keeps doubling, so it looks like we're multiplying by 1/2. So the next one is going to be 1 over 32. All right, the next one, this is the weird one, the Fibonacci sequence. All right, we take 1 plus 1, and you get 2. All right, the next one, 1 plus 2 is 3. Next one, 2 plus 3 is 5. You're taking these and adding to get the next number. Okay, so the next number would be 3 plus 5, and we would get 8. So it's adding the previous 2 terms. All right. Now, notation. How do I separate one term from the next? Okay. So the textbook, so Cognitive likes to use U. I always wrote it with an A. The textbook, Pearson textbook, uses T. It doesn't matter, okay? I like to say the first term is A sub 1. The second term is A sub 2. The third term is A sub 3. So they're all related in that they all have an A, so you know they come from the same sequence. And then to label them, the subscript, so it's kind of like an exponent, but in the bottom, okay? That's kind of what it looks like. It's a little number at the bottom. That tells you where it is in the sequence. So if I asked you for the 100th term, you know that's going to be after the 99th, but before the 101st term, okay? The subscript just tells you where it is in the sequence. It doesn't tell you what the number is, okay? All right, that's very important, okay? N tells you that A sub N or U sub N, whatever you want to use, okay? N tells you location. Okay? It doesn't tell you what the number is, it just tells you where it is, okay? So, let's see, given the sequence, we want to write down the value of the third term, okay? And describe the sequence using an algebraic expression in terms of the term before it. Okay, so the third term would be 1, 2, 3. So U subscript 3 equals 40. Okay, now U sub N is any term in the sequence, okay? Any term in sequence. So we want to find, all right, how do I get it in terms of N minus 1? So U, N minus 1, is the previous term. Because if I was looking for the 5th term, then U of 5 minus 1 would be U4. U4 comes before U5, so it's the term before it. Okay? So, how can we get the term in the sequence? Well, what's happening? I go from 10 to 20 to 40 to 80. I am doubling it. So, I can get any term by doing 2 times the previous term. You can put parentheses around the U times N minus, the N minus 1 term. You don't have to, okay? I just want to let you know that I'm doing 2 times the term before it, okay? That would be your answer. All right, next one. Okay, so let's see. Defining a sequence, there's 2 ways, 2 equations or formulas you can get for any sequence. What we just did is called the recursive rule. It's getting the term, any term, from the term before it. Okay? So if I wanted to find the 100th term, then I would need the 99th. To get the 99th, I would need the 98th. To get the 98th, I would need the 97th. So you see how this would be a problem if I have like a big term, or a term really far into our list. Okay? I don't want to sit there and keep finding the 745th term just to get where I'm going. Okay? So typically what's easier, or what's used more often, is the deductive rule. Okay? So the deductive rule says I can find any term by just knowing where it is, by knowing N. So if I wanted to find, you know, the 100th term, then I would just take 3 times 100 minus 10. So the 100th term of this sequence would be 300 minus 10, or 290. Okay? This is the general term, the nth term. This is the formula that's the best, in my opinion. Okay? More useful. So, given that the nth term is this, and the first term is 2, find the second, third, fourth, and seventh, and state the rule used to define the sequence. Okay, so we're looking for the second term, the third term, the fourth term, and the seventh. We also want any rule, so we want to know how to find the nth term. Okay, so the first term is 2. So to get the second term, we would do 5 times u 2 minus 1. So 5 times the one before it, plus 2. So the previous one was 2, so we're doing 5 times 2 plus 2. So that's 10 plus 2. The second term is 12. All right, now to find the third term. You do 5 times the previous one, which was 12, and then add 2. So we get 60 plus 2, 62. Keep on doing it. Fourth term, 5 times the previous one, plus 2. That's going to be 310 plus 2, 312. Alright, so let's see if we can find an easier way. Alright, we know our pattern is at this point 2, 12, 62, 312. What is happening? Alright, we are doing trying to figure out the pattern. Sorry, I'm sitting here thinking there's an easier way to do it. I think the best way, since we're trying to find the 7th term, is just keep using the recursive rule. So you're going to have to find the 5th term and the 6th term. So you just keep plugging it in. So we're going to do 5 times the previous one plus 2. So 5, that's 1, 5, 6, 0 plus 2. Okay. Then times 5 plus 2, that gets us our 6th term. So 5 times 15, 62. Hold on, let me make sure I'm doing this. 5 times 3, 12. Did I do that right? Yeah. 15, 60, yeah, plus 2. Okay, times 5 plus 2 is 7, 8, 12. So 5 times that plus 2 is our 7th term. So 39,062. Okay, so I'm sorry, it just said state the rule, not find the nth rule. We haven't gotten there yet. So stating the rule, it is the recursive rule, okay, because we had to use the previous term to find the next term. Okay, that's what they were looking for. Alright, next thing, we've got the nth term is this. Find, again, second term, third, fourth, and 7th term, and then state what kind of rule that is. So to find the second term, well, all we need is what n is. So we do 2 squared plus 2 times 2. That's just 4 plus 4, which is 8. Find the third term. 3 squared plus 2 times 3. That's just 9 plus 6. So we've got 15. Fourth term. 4 squared plus 2 times 4. So that's 16 plus 8. So now we got 24. And the 7th term, we would do 7 squared plus 2 times 7. And that would get us 49 plus 14, which is 63. Alright. And the rule it is the deductive rule. Ooh, if I could spell, that would help. That's supposed to be a U. Deductive rule. Because you only need to know where it is in line. You don't need to know the term before it, right? I'm saying that right. Deductive rule. Yeah. I don't know, I'm second guessing myself. Alright, exam tip. Alright, you may be asked to show that a given sequence is arithmetic. To do this, you should find the difference between each pair of consecutive terms and show that this difference is constant. So, show that -7, -9, -11, -13 is an arithmetic sequence. Alright, so that means we want this difference, okay, to equal this difference, to equal this difference. Okay, so -9 minus -7 is, we add, that ends up adding 7, so that's -2. Then make sure the difference here, -11 minus -9 is -2. -13 minus -11 is -2. Alright, the difference is the same. That's how you prove it. Okay? Because how a sequence works is you start with the first term, and the next term you just add the difference. So A plus D. Then the next one after that, you just add D to that. So A plus 2D. And so on. You just keep adding another difference to get the next term. Okay? So, to find what that difference is, you take the bigger number, subtract the smaller number, and you're left with just the difference. Okay? That's how we proved it. We took the second term minus the first, the third minus the second, the fourth minus the third. Okay? Alright, so given that you've got these terms as an arithmetic sequence, write down the expression for the second, third, fourth in terms of the first and D. Okay, so what I mean by that is this is your first term. You know it's an arithmetic sequence. So to get the second term, you would take the first term and add the difference. Okay? To get the third term, you would take the previous term and add the difference. But you know what U2 is, the second term is. That's U1 plus D. Add another difference, and now the third term is U1 plus 2D. Alright, get the fourth term. Take the one before the third term, but I'm going to use U1 plus 2D, and add another difference. Noticing what's happening? Alright, hopefully. Alright, every time I'm adding another difference. So, to get the nth term, to get any term in this sequence, okay, you're going to take the first term, always the first term, U1, okay. Oh, I don't know why I wrote an A there. Sorry. Gotta get used to cognitive. Right. So the first term equals, not the first term, the nth term equals the first term plus some number times our difference. Okay, so we know it's going to be a difference, but how many differences? Let's notice something. I know that for the fourth term, I multiplied by 3. Okay, then then the third term, I multiplied by 2. And in the second term, I multiplied by 1. Okay, that would just be a 1 there. So, notice it's just 1 less than whatever n is. Alright, so this is an arithmetic sequence. The nth term is equal to the first term plus the difference times n minus 1, where n is where it is in the sequence. Okay, so exam tip. Alright, the word hence means that you need to use the previous result in this part of the question. Getting the correct answer using a different method will not get you any credit on the exam. So here when it said hence, deduce an expression for the nth term of the sequence. So you had to do this first part to solve B, okay? If you didn't show that first part, given that it's an arithmetic sequence, write down the expression, it wouldn't have gotten you any credit. Another tip, all right, the formula booklet gives you this. You will be given that equation, okay? You're not given much else about it, all right, but you should recognize that that is an arithmetic sequence, okay? Important, okay, another tidbit from Cognity. So the nth term of an arithmetic sequence is given by u sub n, all right? Okay, this right here is notation, okay, where n is an element of integers, okay? Z plus, okay, Z represents a positive integer, okay? Z is, that's how you get into subsets, whole numbers, things like natural numbers, counting numbers, things like that. I can explain that to you later if you want, but for this, you just want to recognize that Z represents integers. What this means is that n has to be a positive number, okay? Why does it have to be a positive number? Well, n describes location, right? N tells you where it is in line, okay? If you're first in line, fifth in line, 100th in line, well, what can't you be? You can't be 1.3 in line. You can't be negative 17 in line, okay? You have to be that whole number, okay? So how they describe it is n is an element of the set of positive integers, okay? That's all it means, okay? All right, so Nurat is training for a marathon by running 1 kilometer further each week than she did the previous week. Determine how far she'll run in the 20th week of training if she runs 2 kilometers in the first week. Okay, so in week 1, she goes 2 kilometers. And each week after that, she adds another. Okay, so week 2 would be 3. Week 3 would be 4 kilometers. Week 4 would be 5 kilometers, and so on. So how far does she run in the 20th week of training? Okay, I mean, here we want to find the pattern. So we know to find, silly A again, UN equal, I'm sorry, the nth term equals the first term plus n minus 1 times d. And we want to find the 20th term. Well, the first term is 2, and the 20th number in line, so 20 minus 1, and the difference is 1, running 1 kilometer each week. So 2 plus 19 times 1, so she runs 21 kilometers. That was kind of an easy one, kind of lame numbers in my opinion. They get more complicated than that. Okay, but this is how you show your work. Like, I know some of you guys could have just guessed that or thought of that in your head, but you got to be able to show your steps. Okay, all right, let's keep it rolling. Okay, the number of seats in a stadium follows an arithmetic progression. Okay, so the first row has 40 seats, second row has 45 seats. All right, which row will have 100 seats? Well, to find the nth row, you would take the first plus n minus 1 times the difference. It's d. Alright, so we don't know which row. Okay, so we don't know what n is. Alright, but we know the first row has 40. Don't know where it is in line, but we know the difference, each row adds 5. But we want to know which row will have 100 seats. So the term has to have 100. So it doesn't equal the nth term. It now equals 100. Okay, so we move the 40. I get 60 equals 5n minus 5. I distributed this 5 and moved the 40. Add the 5. We get 65 equals 5n. Divide by 5. We get 13. It's the 13th row. That's what I was asking for. Okay? Next one. An arithmetic sequence has a 5th term of 18 and an 11th term of 27. Find the common difference, first term and general term. Okay? Well, let's label it. I've got the 5th term is 18, and then I have more terms in between, and then I have, well, here, I'm going to let you guys visualize it. 6, 7, 8, 9, 10, 11 is 27. So the 11th term is 27. 6, 7, 8, 9, 10, 11. Okay. So I want to figure out what happened here. Okay. Well, you can write it out and visualize it, okay, or we can make it kind of like a mini sequence inside of it, right? That's what I like to do. So for now, I'm going to rethink of this as the first term and rethink of this one as, which term do you think? A lot of people say the 6th term, but it's not. It's the 7th. Count it out. 1, 2, 3, 4, 5, 6, 7. Okay? 11 minus 5 is 6, but 5 is also a term. So you have to do 11 minus 4, okay, to find how many numbers are in that sequence. Okay? So we have the first term and the 7th term. Well, think about it. The nth term is found by doing the first term plus n minus 1 times the difference. So in this case, the nth term is going to be our 7th term, or 27. So 27 must equal the first term plus, that was the 7th number in line, alright, times the difference we don't know. 27 equals 18 plus 60. So then we get 9 equals 60. Our difference is 9 over 6, or 3 halves. Alright, so first thing we wanted to do is find the difference. That's 3 over 2. Alright, now let's find our original first term. Okay, so let's find our first term now. There we go. Why it wasn't working. Alright, so now let's go back to our original equation. Okay, now we have our first term, our 5th term, and 11th term. We just do it again. Alright, our 5th term is 18. We don't know what our first term is. We know that 18 is the 5th number in line, so 5 minus 1. And the difference, we don't know. That was silly. I don't know why I didn't put what the first, what the difference is. The difference is 3 over 2. So we get 18 equals the first term plus 4 times 3 over 2. 4 times 3 over 2 is just 6. 18 is the first one plus 6. Yeah. So the first term is 12. Okay? And then a general term is just the nth term. So it wants to know what the equation is. To find the nth term, we take the first term, which is 12, plus n minus 1 times our difference. And there's our final answers. Okay? Alright, so given that the 3 terms of an arithmetic sequence are 2n plus 2, 4n minus 4, 3n plus 2, find the value of n. Okay, so we know this is an arithmetic sequence. They share that same difference. So let's find out what that is. Take, this is the first term, this is the second term, and that's the third term. So A2 minus A1 should be the difference, and A3 minus A2 should also equal the difference. So let's figure out what that gives us. We get 4n minus 4 minus the first term, which is 2n plus 2. Okay, and that should also equal the third term, 3n plus 2, minus the second term, 4n minus 4. Now notice when I wrote the second term and the first term, right here, with those, I put parentheses around them. That's because I was subtracting and I want to make sure that you distribute that negative. So you get 4n minus 4 minus 2n minus 2, 3n plus 2 minus 4n plus 4. Came out a little funky. So then we get 2n minus 6 equals negative n plus 6. Move the n over, we get 3n minus 6, add the 6, we get n equals 4. There you go. You found it. And to double check it, you can plug it back in. So 2 times 4 plus 2, what is that? 8, 10. Our second term would be 16 minus 4, which is 12, and then 12 plus 2 is 14, and that is an arithmetic sequence, so that looks good to me. Alright, sigma notation. Okay, I'd pause it and write this stuff down. Okay, basically, when you have this big old E, alright, it's a shorthand way of writing out your sequence. Okay, this is your nth term. However you get your nth term, whatever equation you use is right here. This starts your n, usually it's 1, okay, and then it goes to, you know, whether you want to find the 15th term, 17th term, all of them, okay. Now, when you find all those terms, you're adding them up. So sigma means sum. Okay, we're adding up all these terms. Instead of just putting a comma between everything, we're putting an addition sign. Okay, so let's do a problem. Okay, that's going to help. Okay, so here's my problem. I want to find all the terms from I equals 1 to I equals 5. Okay, so the first term, so A1 is when I do I equals 1. So we do 2 times 1 plus 1. So we get 3. Alright. The second term is when we do the next one after 1, is when I is 2. So 2 times 2 plus 1, that's 4 plus 1, 5. Third term is when I do I equals 3. 2 times 3 plus 1, 6 plus 1, 7. Fourth term, that's when I do I is 4. 2 times 4 plus 1, 8 plus 1, 9. Fifth term, that's when I is 5. And that's important to notice, that's where we stop. We're plugging in all the numbers from 1 to 5. I is 1, I is 2, I is 3, I is 4, I is 5. Say that 5 times fast. So 2 times 5 plus 1. We get 10 plus 1, 11. Alright, and that's a perfect arithmetic pattern, so I know I did it correctly. Alright, now, sigma, the whole point of this was to add them up. Okay, so let's literally add them up. 3 plus 5 plus 7 plus 9 plus 11. Let's see, what is that? 10, 15, 35? That's our answer. You find your sequence and add them all up. Okay? Alright, do another one. Okay, so we're going to plug in the number at 4, plug in the number at 5, 6, 7, 8. Okay, so the first one we're going to do 4 cubed minus 4 squared. Ugh, I don't want to do this. 16, what is that, 64 minus 16. I'm just being lazy. What is that, 58, 48. Okay, fifth term, 5 cubed minus 5 squared. 125 minus 25, that one's a lot nicer. 6 cubed minus 6 squared. I'm going to really test my abilities here in a minute. That is 216 minus 36. Okay, so what is that, 180? I really hope I'm doing this correct. 7 cubed minus 7 squared. 343, I want to say. I'm going to get out the calculator. I don't want to mess things up. Yeah, I was right. Minus 49, 294. Okay, 8 cubed minus 8 squared. So that's 512 minus 64. 512 minus 64, lots of extra numbers there, 448. Right? That doesn't seem right. I'm going to double check that. Yeah, okay, I was right. Alright, so now, add them up. Okay, so we're going to have 48 plus 100 plus 180 plus 294 plus 448. 1070. Sweet. Okay. So, how do we prove an arithmetic series? Okay, there's an actual formula to find the arithmetic series. Okay. I don't know if you noticed it. This is the actual proof of it. I think it's easier to show with numbers. Okay, so look at our, I'm going to use numbers that are easier to add. Okay, so 3, 5, 7, 9, and 11. Okay, notice what happens when I group these a certain way. When I group 3 and 11, I get 14. When I get 5 and 9, I get 14. And notice what 7, it doesn't have a partner, but it's just half of 14, right? Well, notice how many numbers I have, okay? Basically, I can say each number is 7. And how did I get that? Because it's the way they group together, they pattern up, okay? So, we can take the first number and the last number, and that represents each pair. So if I figure out the first number plus the last number and take half of it, well, then I can multiply by how many terms there are. Okay? That's the formula. Okay? This is the actual proof of it. Okay? So I know some of you guys looking at that. Alright, so important, there are two formula that can be used to find the sum of the first n terms. Okay, they're exactly the same. One is just written out exactly what the nth term is. Okay, because notice the nth term is just the first term plus n minus 1 times d. Well, when you add, the first term there, that's where that came from. All right, that whole thing, they're the same exact equation, they're just written differently. Okay, so I just wanted to notice that. Okay. All right, so we want to find the sum of the arithmetic sequence. All right, we have 3, 15, 27, 39, and 135. Notice that it gave us the last term. So we want to find the sum of the first 12 terms. Well, the sum of any number of terms is just n over 2 times the first term plus the last term. So replace that n with 12, because that's how many terms we have. We're going to do 12 over 2 times the first term, 3, plus the last term, 135. So really we're doing 6 times 138. All right, and let's see, 6 times 138 is 828. Okay? Equations. I just don't want to give you something that has like all these weird properties. I want to solve something right. Yes. All right, so the next problem is an arithmetic sequence is given by the general term. Find the sum of the first 10 terms. So the sum of the first 10 terms would just be 10 over 2 times the first term plus the 10th term. So let's find out what those are. All right, the first term is negative 121 plus 18 times 1. So what's that? Negative 121 plus 18, so we get negative 103. The 10th term is going to be negative 121 plus 18 times 10. So negative 121 plus 180, so that's going to be a positive 59. So we plug that in. Sum of the first 10 terms is now 5 times negative 103 plus 59. So 5 times, what is that going to be? Negative 44. And 5 times that is going to be negative 220. There's your answer. All right, an arithmetic sequence has a first term of 20 and a common difference of 13. Identify which term is equal to 228, and then find the sum of all those terms. So we know to find the nth term would be the first term plus n minus 1 times the difference. So let's plug in what we know. We know the first term is 20. We know that the difference is 13. We want to know which term it is, so we don't know where it is in location, but we know the actual term is 228. So a sub n is 228. Then we just solve. So 228 equals 20 plus 13n minus 13. So 228 equals 13n plus 7. Subtract the 7. Then divide by 13. What is that? 781. What? Am I doing that right in my head? Probably not. 221 divided by 13 is 17. Oh, not an 8. 7. Okay, so it is the 17th term in location. So we want to find the sum of the first 17 terms. We would do 17 over 2 times the first term, 20, plus the last term. All right, so let's work it out. 17 divided by 2 times 248 is, sum of the first 17 terms is 2,108. There's your two answers. All right, the arithmetic sum of the first n terms is given by this. Find the first term and the common difference. Okay, so I know that 5n minus 11 represents the first term plus the last term. Okay, so if I know 5n minus 11 equals the first term plus the last term, well, think about how you get that last term. All right, we get that by taking the first term plus n minus 1 times the difference. Okay, so let's see here. Wait, I think I just dug myself in a hole. Nope, this is not how I wanted to do this. Nope, I'm starting over. Sorry. Sometimes that happens. Give me a second. Okay, let me refresh this. I don't like where I was going. It was too many variables. Okay, let me think of something else. Okay, so they gave us the formula for the sum of the first n terms. We want to find the first term. Oh, so what if we found the sum of the first term? Wouldn't that give us the first term? So that would be 1 over 2 and times 5 times 1 minus 11. Okay, so 5 minus 11 is negative 6. Half of that is negative 3. So the first term is negative 3. Perfect. All right, the sum of the next two terms. All right, let's do 2 over 2. 5 times 2 minus 11. That gets us negative 1. Well, if the sum of the next two numbers is negative 1 and the first number is negative 3, all right, then the second number, okay, negative 1 must equal negative 3 plus the second term. Again, the sum of the first two terms is equal to the first term plus the second term. So that sum, which was negative 1, is equal to negative 3 plus what? So 2 is the second term. Okay, so let's see what they want to find. The first term, so the first term is negative 3. We found that out. And the difference is just the second term minus the first term. So 2 minus negative 3 is 5. Okay, so our difference is 5. Okay. All right, consider the sequence. Find an expression for the general term to show that this is an arithmetic sequence. Okay. Okay, so this one's a lot like the last one. Okay, so we want to show that, or we want to find the general term. Well, remember what I just did. Okay, the you can find, I don't know how to explain this. Okay, to find the nth term, you can take any sequence, the sum of n terms, minus the sum of the n minus 1. So like, let's say for instance you were trying to find the fifth term. That's the sum of the first 5 terms minus the sum of the first 4 terms, right? You just take away those first 4 terms and you're left with the fifth term. That's what I'm trying to say here. So let's actually work it out. Okay, so the nth term, well, we know what s sub n is. It's 2n squared minus 3n. Then we subtract the n minus 1 sum. So that's going to be 2 times n minus 1 squared minus 3 times n minus 1. And we literally work it out. Watch your signs. Don't want to mess anything up. So this is n squared minus 2n plus 1. You got a FOIL there. Make sure you're foiling. Then we have this. So 2n squared minus 4n plus 2 minus 3n plus 3. Okay. So we're going to have 2n squared minus 3n minus 2n squared minus 7n, so plus 7n plus 5 minus 5. 2n squared is minus cancel, so 4n, sorry I'm rambling, 4n minus 5. So the nth term, you can get it by doing 4n minus 5. Okay, so that's the general term. Alright, it was gross, it was nasty, but I simplified. all right, and show that it's arithmetic. Okay, so let's see, we can do this, if I remember correctly, your book did it this way. If you have the term before it plus, minus the nth term, you're going to get the difference. So the fifth term minus the fourth term is going to be the difference, right? So what is the n plus 1 term? Well, that's just 4 times n plus 1 minus 5 minus the nth term, so 4n minus 5. And that should be our difference. So we get 4n plus 4 minus 5 minus 4n plus 5. That's nice because a lot of stuff cancel, and we get 4 equals d. So our difference is 4. Our difference is common. It's constant. It's never changing. We should not get something with a variable. So this is great news. Perfect. All right, so consider this sequence. Find an expression for the general term and show that it's an arithmetic. Wait, didn't we just do this? Yeah, we just did this one. Awesome. My bad. All right, keep it rolling. Applications. All right, the height of each step is 20 centimeters. The first step is 25 centimeters above the ground level. How many steps would you need to climb to be 205 centimeters above ground level? So we want to basically know where that is in the sequence. All right, we're starting with 20. We're starting with 25, and we're adding 20 every time. We could sit here and count, but who's got time for that? So we use our nth term, it's found by this formula. Plug in what you know. First term is 25. We don't know where it is in the sequence. We know the difference is 20. And we know a sub n, that nth term, is 205. Work it out. So we subtract, we get 180. I just like writing it with the 20 in front. And then we divide by 20, we get 90. So we're going to need 91 steps to make it to 205 centimeters above ground level. That sounds like a lot of steps to not go very far. All right. Let's see. It's another international mindedness. It is important to keep in mind that different cultures have different norms about how customers are charged for a service. In some cultures, it is acceptable to charge an initial flat fee. All right, such as a plumber example. Oh, that was a previous problem. All right. So while in others it is only acceptable to charge money specifically for the services provided. You want to keep those things in mind, okay? We always think about adding tip or adding, a flat fee plus per hour. It's not always like that in different cultures. So just because we do it a certain way in Tallahassee doesn't mean that they do that the same everywhere. I mean, heck, it could be even different in Alabama, okay? So just keep things in mind on the culture around you. Okay, so it costs an initial 20 zlotys. I don't know how to pronounce that. I think it's Polish money. I think that's what it was when I looked it up. For a plumber to come to your house, and an additional 3 zlotys for every hour that the plumber spends on the repairs. So write an expression for the total cost of the plumber's visit that includes n hours of repairs. So this is what that international mindedness we were talking about. So you are going to start with a $20 flat fee, and then you're going to 3 zlotys for every hour. So adding 3 times z. Okay? So hence calculate. Okay, so this is the cost of repairs. In hours of repairs. Oh, I'm sorry. That should be 3n. Ooh. Sorry, it's not recognizing my pen. Oh, goodness. Okay. So, So now that we've wrote an expression, we're going to calculate the total amount that you will have to pay if the repair takes 5 hours. So that's all you do is plug it in, 20 plus 3 times 5, and that's, notice this is an arithmetic sequence. Okay, so this is going to get you 35. Yeah, that was pretty basic, but it's just understanding the word problem. I think that's what throws people off. Okay. All right, so now we got a supermarket display. Let's see. At the top of your calculator, okay. So we start with 28, and then we keep losing 3 boxes every row. Okay. At the top of the pyramid has 1 box. Okay. Calculate the total number of boxes used in this display. So we know the formula is, or the pattern goes like this. So 1 plus 4 plus 7 plus 10 all the way up to 28. Okay, so I don't know how many rows I have, and that would help me in knowing how many pairs I'm going to have to do the sum. So let's figure out what number in line 28 is. So we plug all that into our formula, and we get, sorry, it takes a second to work it all out. Then we get 10 rows. Okay, so we need 10 rows of boxes to now figure out the sum of those first 10 rows. 10 over 2, and then 1 plus 28, first plus the last. Okay, so now it's just 5 times 29. So that is going to be 145. That's how many boxes you need. Okay, so she's got 4,000 rubles. We want to write down the amount that is in her account at the end of each of the first 5 years. Okay, so we are going to add 4% of her initial investment to be added to her account at the end of every year. So her initial investment is 4,000. So after year 1, we're going to take that 4,000 and we're going to add 4% to that. So 0.04 of 4,000. Okay, so that is going to be 160 plus 4,000. So at the end of year 1, she has 4,160. At the end of year 2, we're going to take that 4,160 and we're going to add 4% of that. Okay, now I could sit here and do 0.4 times that and then add 4,160 to it, or I can just multiply by 1.04. Okay, that gets us our initial 100% there and plus 4% there. So 1.04 times 4,160 is going to be 4,326.4. Year 3, she's going to have 4,499.46. We rounded. I doubt the bank would round up, but we're going to do it that way. 1.04. So year 4 is going to be 4679.43, and year 5 is going to be, ooh, that looks really rough. Year 5 is going to be, sorry, times 1.04, 4866, 4866.61. Okay. So, let's see, write down the amount that's in her account at each 5 years. Okay, so now write a general equation for A. The amount of money that she has in her account in terms of T, the number of years. So, okay. All right, so I feel like I feel really silly because that was a geometric problem what I was doing, and we are definitely only in arithmetic stuff. It said 4% of her initial investment to be added to her account at the end of every year. So not her, it doesn't change what she adds. She's still only adding 160 at the end of every year. So at the end of year 1, she has 4,160. At the end of year 2, she's going to have 4,320. At year 3, she's going to have 4,480. Year 4 and year 5. Year 4 is going to be, what is that? 560, 660. 4,660, and then add another 160. We're going to have 4,000. Nope. Nope, I can't add. This is why I use a calculator sometimes. Plus 160 is 4640. There we go. Plus 160. Now we're cooking. Okay. So we're adding 160 every year. Write a general equation for A, the amount of money that she has in her account, in terms of T, the number of years. So, in her account, she has 4,000 in her account, plus every year she adds 160. All right, deduce how the equation from part B is connected to the arithmetic sequence. Well, we can actually tell that this is connected to the arithmetic sequence because that sequence is just this. 4,000 plus 160n is the same thing as our equation. Okay, so of course it's going to be the same. All right, that's how we can deduce that this is all working out. The equations match. Okay, so interest problems. We have A equals P times 1 plus RT. This is not given in the IB booklet, but we can think about it. It's easily modeled after that arithmetic sequence. Okay? Because think about, this is just, how do I explain this? It's the same idea, okay? Because what did we do for the rate? We were multiplying by the principal times our rate to get that second part, okay? It's just another way of looking at it. That's all I wanted to show you, okay? Let's see. Not all real life examples involve adding and subtracting. All right, so consider these examples. We have this number of bagged potatoes and then the mass. It doesn't, I'm asking, does it follow an arithmetic progression? Can you make predictions about the mass of 10 bags of potatoes using what you know about arithmetic sequences? Okay, so we can't tell right off the bat, right? If it's not so blatantly obvious, okay, like most science is, okay, data that you get is not going to be that obvious. Do your differences, okay? You take the second term minus the first, and you should get the same difference as taking the fifth term minus the fourth. And that's what they did here, right? They found all the differences, and notice that it's all pretty darn close to each other, okay? So it almost follows this arithmetic sequence, and that's what it's talking about here, okay? It's not technically an arithmetic sequence, but they're close enough that you can approximate the data, okay? So we find the average, okay? We find the average difference and get 6.07, and then we can find an average equation, okay? An average, you know, our best guesstimate, you know? So let's see. I don't think I wanted all this. Yeah, this basically just talks about how it's not exact, and that's what we do is we do the law of averages, and we try to model it and use that formula for real world applications. Okay, that's what this whole part of the textbook was getting into. Okay. All right. Next problem. Without any passengers. Let's see. And when there are 40 passengers, the total mass and passengers is that many. Okay. So calculate the mean mass of a passenger. All right. Okay. So we take the airplane has 4,200. So we're going to take that away from 7,480. Okay, and this is how much the passengers are going to weigh. Okay, so that would be 3,280. And since there are 40 passengers on the plane, we want to find the average. So we take 3,280 and divide it by 40. So let's see. What do we get there? 3,280. I've been messing up, so I'm just going to use my calculator. 82. The average weight of a passenger is 82. Yeah. So, hence, write an expression for the nth term that gives the total mass of the plane and passengers when there are n passengers on board. All right. So, to find the weight of the entire plane is 4,200 plus 82. What did they say for n passengers? State the values of n for which your model is valid. Okay. Well, n represents how many terms are in the sequence, right? Which is how many passengers. N passengers. Okay. Well, the plane can only carry 120. So, n has to be somewhere between 120 and nothing. Can we have 0 passengers? Sure, why not? Can we have 120 passengers? Sure can. But that's it. The lowest we can go is 0. The highest we can go is 120. All right. Almost done. I know this is a long one. Okay, when you consider the examples about the mass of potato, okay, that's a shortcut for writing u of n expressions that are not perfectly arithmetic. Okay, so the initial value for n is 0. Okay, where basically this is talking about what we just mentioned about what n could be. Okay, n in this case makes sense that it could be from 0 to 120 when you had your I don't think we did that one. Okay, the big thing here is that how the notation. Okay, so here it wouldn't make sense for you to put u sub 1 for our airplane thing for over here. That is not the first term. This is our initial without any passengers. All right, it's not the weight of the plane with 1 passenger. It's the weight of the plane with 0 passengers. This actually represents u of 0, the initial weight. Our initial part of the sequence. Yeah, so that's what this is trying to explain. Just watching your notation there. Okay. Let's see. Be aware. N is defined as the positive integers because again, n is where you are in line. So I think we talked about that. Let's see. Okay. So, write an expression for u of n represents the temperature of your house minutes after you turn on the heat. Okay, so we know it starts as 15 degrees, and the house rises 0.35 for every minute. How many minutes before your arrival the heat should turn on so the house warmed up to 23 degrees? So we want it to equal 23 degrees. So we solve for n. Okay, so 23 minus 15 divided by 0.35, and we get about 22.86. That doesn't really make sense. So if we want it to be 123 degrees, I would round up here and say 23 minutes. All right, determine whether this model is appropriate if you want to work out the temperature of your house if you leave the heat on for 5 hours. Okay, well, we're talking about it minutes. So 5 hours, I mean, my goodness, guys, we're talking 300 minutes. So 300 times 0.35 is 105 degrees Celsius. Let me write that out for you, okay? 5 hours represents 300 minutes. And if it's rising 0.35 for every minute, we're going to raise 105 degrees Celsius. No, I don't want to be around when it raises like that. Okay, so that wouldn't make sense. Eventually, your house isn't perfectly insulated. Eventually, that heat is going to escape and it's going to stop. Okay, your AC unit's not that good, or your heater's not that good. Okay, that's why. All right, so this is everything you should know. Hopefully, I'm at the end of that chapter. Sorry that one took so long. I tried to go through as many examples as possible. Again, you don't have to watch everything. You can speed through stuff, but I wanted to make sure that you saw me work out every type of problem. All right? See you guys next time.